GPLHOW2G. This one's going to be how to convert using Soundtable Basic program from a basic or extended basic sound file or sound call sound into GPL or assembly. Anyways, we have assembly 1, assembly 2, assembly 3, which is our GPL assembler, basic to GPL, which is our gram file that's created with csave and csave2. Then we have edit 1, which is your regular editor assembler, and then edit and edit U, which is our RAG editor. GPL loader. This is a loads compressed object file created by the assembler. GPL disassembler, just for the fun of it, to disassemble GPL. This file that we created with the assembler. The object file we're going to load with the GPL loader. The source file that we use to show you the source on the GPL program. Then Soundtable is a basic program, and GPL to basic is the listing for it. Now, Soundtable is a basic or extended basic program, and we're going to run it from RXP. And what it does is it converts call sounds over to data tables. That's the reason why it's called Sound Data Table Creator. Now, this is in the Compute's Assembly Language Guide program, a book. So we have a call sound 1111, 110, 0, and that created we use generator 1 through 4, so this is generator 1. I haven't yet figured out how to use generator 2, 3, and simultaneous sounds yet. There's a way of doing it, but I haven't figured it out yet. It doesn't work right. It either discontinues the sound totally, or it just never stops playing. So some next experimentation, and when I figured out the simultaneous sounds, I'll give that to you. So this is another call sound. We're going to do 2 call sounds in one. So basically what we're going to do is we're going to play one after the next one. Because we're just using one generator. We're not using more than one generator. So this whole GPL demo is on explaining how you can use just one generator. When I figured out how to use simultaneous sounds, I'll post a video on it and a how-to GPL on it. So to break this down, we have 03, 8B, 0490, which is 3 bytes, 8B, 04, which is your frequency, 90, which is your duration, and 04, which is your volume, then 00 to end that, playing that list. So this is the other tone that we were going to make up, which is -8, which is works out to be, if you look at it, it says the duration's 9/4, which is -8, kind of weird, but 0380 03 9401 00. Now the volume's 01, the 03 says 3 bytes to follow, so it's 83, same thing, and then 00 ends it. So it works out pretty much the same way for a single tone. It gets extremely complicated when you're doing it in simultaneous tones, which is the reason why it's been taking me so long to put out this video, because I was trying to figure that one out. It's been a lot longer between GPL how-tos because of that. Okay, so this is the data statements that we have. If we take the 2 data statements and put them together. Now, what we can add here is 04, 9F, BF, DF, FF. Now, that turns off all the generators. 04 means 4 bytes. 9F. 9F means turn off generator 1. F is the highest volume, which is 30. BF, which is generator 2, turn off the volume to highest. D, which is generator 3. And then FF, which is our last generator number 4. And then below we have the IO command, which is data and variable. And this is how we're going to use our pointer. So I'll explain that later in the video. Okay, this is going to be a listing of the source file for the GPL sounds demo that we're doing, which is from basic or extended basic to GPL. It's not a very big program. It's mostly a menu system. If you take a look here, the biggest chunk of listing is just simply taking a key from the user and then going to the correct subprogram to play it. The actual sound is just nothing more than just a data line and a double store, which points it into a variable, and then the IO command, which tells it to play that variable list in GPL. Now, you cannot play this in video. You would have to change the IO command from IO 0 at variable to IO 1 in video. This is the reason why you can't use the GPL linker on this, is because you have to convert it over to run it for the GPL linker. The other situation from running it from VDP is, very interesting thing is when you're running GPL from VDP and you're using IO command, some problems crop up. The reason why is because in assembly you can use the limit on and on command. So this is our listing of our program up here. We're looking at the variables first. I was showing you those, and then I was going to show you the header to point to where we're going, and then we're going to go down to our normal stuff, which is just our screen setup. What you're going to see, that's your normal screen setup. I'm going pretty fast here. We're going to set up a keyboard, and what we're going to do is we're going to put on keyboard 3, which is uppercase only. I'm trying to speed this up because it's so huge. And then we scan for a key, get a key. Okay, if it's not a key, then we'll just go back and just do the loop over. If not, we're going to look for character 65, which is the A key. If it's there, then we're going to go to N66. If not, then we're going to double store the file at 16, load the sound list pointer, in other words, at S1620 in the data statement at SOND, which is our variable. If not, they're going to branch to off. Then we're going to do, after we're done with that, we're going to branch to off. Now they're all exactly the same after that, down to here. Where we get to this one, which we'll look for R. That's the last key you're going to press. And you're going to double store that, branched off, and then the space key, which is going to play a sound list, which is our Pop the Weasel sound, which is just Pop the Weasel tune. Here's the main guts of the program, which is off IO. Play the sound list point to about sound. That's an IO command. That's just that simple. Now at the top here we have a thing called aorg, which we're going to pop forward, make sure it's an even address, and it must be on an even address in GPL. True for assembly also. But I discovered to my dismay that if you're an odd address, you get some very weird behavior. So this is our turn off all sounds. We're not using it because I added it to the end of every single one of the call lists. I could have put another IO command in to put that in afterwards, but I just decided, what the heck, I just put it on the call list. I just add those bytes at the all off to every one of them. So this is the first one. You see the call sound in basic. Then you see the entire command, including the all off. I use data statements because you can put these into assembly if you want to. I just found it easier to make them bytes. You can use bytes instead to save memory. So those are all the call sounds, the entire listing. And then at the very bottom, they all look the same. I break them down and used our basic sound table program to make all these. Here's our Pop the Weasel. Now the data statements for the Pop the Weasel list. Now this is our assembly. If you've gone through the first GPL how-to, then you know how to do all these. I may come out with a linker version where you can allow to do it, but I don't think you can do it because assembly allows you to control the interrupts and GPL doesn't, so I find it highly unlikely. But I will work on the simultaneous sounds so that we can figure out how to do that in GPL. There is a way to do it, I just haven't figured it out yet. It's pretty complicated stuff. Okay, now we're going to load the GPL loader to load our compressed object file. So we load the loader, then we go to the GPL object code loader, and we load the object code into GPL. And we're going to load it into, of course, Graham. Classic can do this. All right, now we're going to use csave. We're going to turn the GPL Graham into a disk file to make it a Graham file that we can load. It'll just speed things up here. Just wanted to show you how to do this. You load up csave, disk 1, basic to GPL. It's going to load at C000, which means we're going to use GROM 6. So we're going to turn off the ROM1, which is the D key, is going to be doing that. We're going to turn off the G3 because we're not using the 6000 space in GROM. And we're going to use long GROMs. So that means that they're not short, they're long. And I don't use short GROMs. I never use them. I never will use them. Okay, the meat of the program. This is just going to be me pressing the keys to show you what they do and the tones coming out. Press them several times at a time. So see you next GPL How To.